Thanks for joining me in this video. My name is Jean-Joseph. I'm a data engineer and I work for Microsoft as a technical trainer. Today, we are going to unravel the engineering magic behind a well-structured Medallion data architecture pattern. This pattern is a fantastic way to organize your data, and it's used by many successful companies to make the data easy to understand and use. So whether you are an expert or just starting to understand this wonderful architectural pattern, this video is going to be super helpful. I will break down the complex concepts into simple, easy to understand terms. So sit back, relax, and let's dive into the world of Medallion data architecture together. Let's get started. You're probably asking yourself what I'm going to talk. This is our agenda, okay? And guess what? Let's go to our main concern. What exactly is Medallion architecture? Think of it as a design pattern, okay, used to logically organize data in a lakehouse. The goal is to gradually make the data better, more accurate, and organize as it's moved to different level of the data storage system. In simple terms, it's like cleaning your data step by steps as it goes through different stages. This helps to make the data easier to use and understand. Here's the thing, the key principle of the Medallion architectures rely on three stages. The first one is what we call bonds layer. This is where you're gonna have all your incoming data as well. And those data has to be the same as the source. But in order to promote data incremental and quality, we need to add a couple metadata to that data without changing the state of that data. And those metadata could be a load the time, process ID, application ID, right? However, we have to feed the silver layer, and the silver layer require a clean and confirm data. So therefore, we need to read the bronze layer where we have our raw data, okay? Once we read that, we have to transform that data, conform that data, clean that data. What I mean by remove duplication, outliers, okay? And also understanding when to replace empty value with kind of unknown based on the business requirement. But during the cleansing process, you need to make sure you keep the transaction history because silver layer can play the role of OLTP. And such environment normally use third normal form in terms of data modeling, right? And the silver layer, therefore, can provide an enterprise view, okay, in terms of all key business entities, concepts, and transactions. However, gold need to be fed by the silver layer. But remember, Gold require that data to be aggregated. So therefore, we need to read the silver layer data, apply business aggregation, right? And save that data on the gold layer. But the architecture behind gold layer is to leverage, okay, that data as a warehouse. So therefore, that data has to be denormalized. So this is where the fact and dimension table comes in. So therefore, the data modeling would play a big role in terms of if performance matter or data integrity. So this is where the choice between star and snowflake schema comes in. But you're probably wondering, for example, what would be the benefit, okay, or the advantage of the Medallion architecture. And guess what happened? The Medallion architecture offers several advantages. It provides structured data movement, allowing for efficient organization and retrieval of data. It supports incremental enhancement, meaning you can gradually improve and expand your data processing capability over time. It offers flexibility and governance, enabling you to adapt to changing business needs while maintaining control over your data. Finally, it facilitates advanced analytic and machine learning, right? Providing a robust foundation for deriving insight from your data and building predictive models. These combinations of features makes the Medallion architecture a powerful tool for modern data-driven. So let's consider a business use case, right? Consider, for example, Contonso want to leverage this architecture. And in terms of business scenario, imagine, okay, a large multinational corporation, Contonso, that operate in various sections such as technology, healthcare, and finance. They have a vast amount of data coming from different sources like IoT device, customer transactions, social media, and third-party data providers. The data is divided, unstructured, and in a different format, making it challenging to manage and derive insight. So with that, in terms of business need, Contonso want to leverage this data to gain a competitive edge, improve customer experience, organize operations, and derive innovations. However, the current data infrastructure is silo, leading to data duplication, inconsistency, and quality issue. They need a solution that can handle the volume, variety, and velocity of data while ensuring data quality, governance, and accessibility for advanced analytic and machine learning. So in this scenario, the Medallion architecture could be ideal solutions. Okay, now let's go over the demo to explore the amazing data storage design pattern. This is our notebook, okay? And as I already explained, the bronze is where we will have the raw data. It's going to be our landing zone. The silver is where we will store the clean transactional data, okay? And the gold is where we will store all the aggregated data and save that as a knowledge base for business to be able to perform analysis, right? And then now um, we have to access the data from the bronze layer. As you can see here, this is where our file is located, and we are about to read the entire CSV files, and this is where the file is located. If I click on this one, you can see that those are the files we are about to read, right? And you may notice we don't have any table yet, right? So what I'm going to do now is I'm importing all SQL types for me to be able to define the schema definition. Here is that instead of I let Apache Spark define the schema, I explicitly define it myself. And then what action I'm performing, I want to read what would be the file extension. It is a CSV. Is the file has header? Yes, it is. And this is where I pass the schema definition, as you can see here. And this is where I pass the location where the file are located. If I execute this, here you should see there will be file record return because we tell it to just return the top five. Now we can explore that data. We as a best practice, right? We need to get some statistic against that data. Okay, we need to get that. So what I mean by we cannot quickly perform any, for example, operations without having a great understanding of the underlying data set. I'm gonna share the notebook with you. Once you download it, you are free to read all these notes. Otherwise, the video would be very great. So here, what I'm using is that I'm using a couple fields from this DF bonds data set. If you remember this data set that we created here, okay? And I am leverage summary functions. Summary functions is used to generate descriptive statistic of a data frame. For example, if I execute this, what you expect to get is that it provides insight into the central tendencies, dispersions, and shape of the distributions of the data set. This can be useful for understanding the data, identifying outliers and anomalies, and informing data pre-processing decisions. It's a common steps in exploratory data analysis. Okay, and then now you can see now I'm getting some good insight out of that data here. Okay, take a look, getting some good insight, but we still not there, okay, to think that we are ready, right? So it's always great to understand if the data has empty value or null value, and most of the time we might need to replace them with something else. And if we don't need them, we will need to remove them. This is what I'm doing here. Okay, I'm checking if there are any null value or, for example, empty value for each column. Now I can see some column has no null or blank value. Some column also, for example, has no null or blank value. So therefore, we can see the data is kind of clean, perfect. So now let's perform some transformation. Okay. Here, what I'm performing is that I am adding some transformation against that data set. The kind of transformation that I'm doing, I'm adding the file name, and also I'm adding a flag. This is a boolean, right? And I want this to be true if the order date happened to be before this date. Otherwise, I want it to be false. It's like 1 and 0. And also, I'm adding two more columns. One is created and modified date, okay, timestamps, okay. And I'm using the current timestamp functions. So also, customer name is critical for us. We do not want to load that data empty. So what I'm doing here, I am checking if it's null, okay? This is what I'm doing, or if it's blank. If it is, I want this to be unknown, Otherwise, I want the customer name to be returned. When I execute this, you should see that those colon will be added accordingly. As you can see here, we add those colon here. Okay, this is the flag. We just add it. Okay, and then this is the flag. This is the file name, as you can see here. Okay, now the data is clean. We have a clean data set, right? We cannot save that data on the bronze layer. So that data has to be saved under the silver layer. So this is where we will need to think of getting ready for the silver layer. But here's the thing. In order to get ready for the silver layer, we will need to define the table structure. This is what I'm doing here. And the goal of this script is to create an empty table. So let's create it, and the name we're gonna give that table is sales silver. Once I execute that table, the script, what you will need to see as soon as the completion is done, if I refresh this tables, you will see that the silver table will be show up. So it might take another 3 more seconds. Let's give it sometimes. Not sure why it's taking that long. It's normally take okay, way less time than that. You know, when you're doing demo, that's how things go. Yeah. So now it is completed. If we refresh this, take a look, and if you remember, we didn't have silver. So if you come back here, you click here, you should see that now we have silver. And if we click on silver, you expand this, you should see we have the silver table the way we asked it to create it. But here's the thing, this is an empty table for your information, and this is an external table type. If we execute this, you will see that this is an external table type. Take a look. If I take a look, the table type is external, so therefore it is not managed, right? So if you delete the table, you just delete the metadata, the file will still be there. If you delete the file, the metadata will still be there. They are two independent. However, if this one was managed, if you delete the table, the files will be deleted as well. So now here's the thing, and now we create the table. What we need to do is to load that data. Creating that table could have been done like this as well, right? So now let's check to see if we have data. So you can see that there is no data available. Let's populate the data. So here's the thing, you cannot quickly leverage the data frame and write that to the silver table. The reason why is you have to think of the incremental load. So with that, we have to go with what we call merge. So if you see here, we are leveraging a merge operations. If you remember this data frame, this is DF update from bronze. Okay, let's go and have and show you where this one it's coming. This is where it's coming. Okay, so now that data need to be inserted into what we call the silver. So we rename it as df update, and within that df update we alias this as update, and then we have the silver uh, sales order id. Okay, those are the criteria for the merge to be occur. We have order date, and then we have customer name. Okay, and we also have item. So if you pay close attention, you will see that this is the delta. Okay, and then this is the merge operation. This is the update. See, so this is the delta, the silver table. This is the update. Okay, the bonds data, the one we just cleaned and we kept the transaction history, and we want to update the record if the record existed, and if not, we want to insert it. That's what I'm doing here. If I execute this, you should see that the data now, if we issue a select, or we want to perform some analytic against that data, we should be able to do that. As you can see here, now we should have a table, and this is the table, right? As you can see, we have those record. So here's the thing, the silver layer is done, right? So now the silver layer hold all clean transactional history data. The silver layer doesn't have any information that can be leveraged as a knowledge base. This is where you have to think of the gold layer. And the intent of the gold layer, okay, is to save all the aggregate data based on business requirements. And guess what happened? If you recall, I mentioned the silver layer can be treated as a third normal form, right? However, for the gold layer, the data has to be denormalized. And with that, we need to understand what type of data modeling we have to go with. Should we go with star, or should we go with snowflake schema? But however, remember, when we want to populate the objects for the goal layer, we need to think twice, okay? In our case, we will focus on star schema. And remember, star schema is a combination of two types of tables. You have a fact table that holds all the quantitative value, all the measures, along with the surrogate key. Surrogate key are the primary key that come from the dimension, and the dimension hold the descriptions. So with that, it doesn't matter the type of slowly changing dimension. It is ideal to load the dimension tables first, because fact table is a combination of two types of fields. You have the keys, the unique keys from the dimension table plus the measures. Perfect. So with that, let's go and create the gold layer against the silver data. So that's what we're doing here. So what I'm doing here, for example, I'm trying to read the silver data. So you can see this is my lake house right here. Okay. And this is my silver table right here. Okay. And I'm returning the top three. So let's execute this. So now what we will need to do is to create, um, uh, this is the data that we have. What we need to do is to create the Zim customer, the Zim date, the Zim product, and fact tables. So let's start with the Zim tables. A Zim tables is very useful for time-based analysis, right? So let's create this. So what I'm going to do now, we're gonna add one more layer. If we refresh this, you can see we don't have any gold layer, right? So what I'm going to do now is to create the Zim table under the gold layer. So this is what I'm doing. I'm defining the structure of my table, like the schema definitions, and I want to write this table as a delta and override it if it exists. So this is the location you have here, and this is the table name. Okay, so let's execute this. Once the completion is done, we should have one extra table here, and that table would be empty. And we should also have one extra file directory here, as you can see here. And then here, if we refresh this, you should see we have one more table, and this is a dim date. And guess what happened? If we select from this table, it should be empty because the data is empty. And then now what we need to do is to populate that data. But before we populate that data, it is ideal to verify if whatever we did make sense based on business requirements. So you can see I'm getting the day using day of month from this column. I'm getting the month. I'm getting the year. I am also formatting some data to get the month and year. And okay, and also I am getting the year and month as you can see here. And I'm ordering by ordered it and return top three just to see if the modification happened to meet business expectation. As you can see here, we got what we want. Perfect. So now we need to populate that data. Remember, we cannot use, for example, append here because we need to think of the incremental load. So with that, this is our date table, okay? And then this is our update that's the dim date goal, okay? So and that dim date goal come from here, the modification we just did, okay? What I'm doing here, if the data there, I want to update it, otherwise I want to insert it. Once the executions is done, I must be able to select that data and take a look now. The date there must be data, and we need to perform same for a Zim customer. If we refresh this, you should see that we should have, for example, we don't have Zim customer. Okay, now we're gonna create Zim customer. So this is the definitions of Zim customer table. Okay, that's the schema, the definition, and this is where we are creating the table. Let's execute this, and this is an empty table. So let's give it a second. Once the completion is done, you should see that if we refresh this, we have Zim customer, and here we must have another file on the goal layer. Let's refresh it. Now we have Zim customer and Zim date. So now what we need to do now is to make sure we can access that table, and there must be no data because we just created. And then what we're going to do is to get the data ready for Zim customer. Remember, Zim customer has the full name, if you recall that. Okay, so what we need to do is that I am getting the Zim customer and I'm getting the email. Within that Zim customer, okay, I need to get the first and last name. So what I'm doing here, I'm adding the first name based on a condition. I split that data and I get the first index ID as the first name, and I get the second index ID as last name, and I'm returning that data. If we execute this, you should see that it gives us what we want. This is the full name, this is the email, this is the way we split it. So now the information we need is those, okay? We need to populate that data. But here's the thing, in order for us to populate that data, we have to be able to join that data. So with that, we will need to bring customer ID, okay? But in order for us to get customer ID, we need to take advantage of customer name in order to join and bring that ID back. That's exactly what the script is doing right here. If I execute this, for example, you should see that it will return what we call the customer ID here. Perfect. So now we got that customer ID. We will need to perform the same kind of offset to generate that data. As you can see here, that's the exact same thing we're doing. Okay. Now let's execute this. We should get data now. Take a look. Now, if we execute this, we get data. So we will need to perform the same for Zim Product. So let's create Zim Product. The definition of Zim Product uh, is this one. That's the schema, the definition. And here is where we are creating it. Perfect. Let's execute this. Once the executions is done, all we have to do is to refresh this. You should see there will be more, for example, um, folder created, and there must be one more table exist. And this is all empty, and we will need to populate that data as well. This is what we are doing here. So if you pay close attention, is that we are performing some operation. So we get the item name, we split it, and we base on a comma, and we get the index 0. We get the item info. We perform, for example, a case statement, and we split it, and we make sure that based on this one, we get the item 1. So what we do, we generating this the data for the product. If I execute this, you should see that. Now, if I click here, you will see that 58, this is 58. This is the operation we were doing. And if I click here, there should be 42. This is the 42. And if I click here, there should be blank. This is blank, a black. So if you see here, that's the logic we have performed here. So perfect. Now the data is ready. That data, we require the item ID. So in order to bring the item ID, um, for us to be able to join that data, that's what we are doing here. If I execute this, okay, you will see that the result bring us the item ID based on the conditions we have performed here. And remember, that's what we did. Perfect. So now let's populate that data. If we populate this, and then we query that data, if you remember, this was empty after the creation, but if we refresh this, we query that data, there must be data there. As you can see, perfect. So now, here's the thing. We will need to create the fact table. That's the schema definition for the fact table. This is the name, okay? And then this is where we tell it for the file to be resigned, okay? And then this is the table name. So now let's execute this. You should see that that data, okay, is there now. Let's refresh this. Take a look. We have Zim customer, we have Zim date, Zim product, and fact sales. So now we can perform operation there, as you can see here, right? So perfect. So there is no data. Let's create the data. So in order for us to create the data, so we need customer and Zim product. So those ID, we have to bring them over. Okay, those are the ones that carry the entire description for each transactions. So if you remember with the item, when we split it, we get that item ID. That's the same logic we are performing here. And then here we are creating the gold sales data frame. Okay, so take a look. We defining the column. Okay, this is the date, the quantity, the unit price, the tax. And if we execute this and we wait for the result set, you should see that it gives us what we want. How cool is this? Right? So now we have customer ID where we can join this with the customer ID. If you remember here, okay. We have item ID. If you remember on product, we have item ID, and we have order date. If you remember on Zim cells, we have order date. So when we creating our semantic model, we can define it very well. Perfect. So now let's insert that data. It's going to be the same logic. Okay. So let's execute this and take a look. We should see we have data on the fact table now. Let's return this to let's return just top 3. So as you can see, now here's the thing. We can create a semantic model out of that medallion layer. But here's the thing. You can even go and create a schema and create a view to assign them. What I mean by, let me show this to you. I'm gonna go back here and click let me go back here. Let me click here. I can click on lake house and then come back here, create a new, say create schema. Okay, silver. I'm it's already created, so we don't need to worry. We can create another schema and call this goal. Okay, so now we can create view. Okay, we can create view now. We can create view and say select. Okay, everything from DBO that let's call this DBO that Zim customer, and let's call this Zim customer. That's the view. Okay, so we have that view up and running. Give me a second. They said sorry about that. Let's call this call customer. Okay, so we have that. We can have this as Zim date, and we can create that as the, and then we can say Zim product, and then we can create that as product. Okay, and then we can say fact. We can create that as fact. Okay, so now here's the thing: we can have the application team connect to this instead of the application connect directly to your, for example, physical underline table. If we refresh this, we should see there must be a new schema created. That schema called silver. And then if let me go for gold, hold on, I'm not seeing why the computer is a little bit slow. So now if you go under gold, you go to views, you can see that now everybody point at the view. Okay, customer, Zim customer, Zim date, Zim product, and fact. And same thing can be done for silver as well. So here's the thing: if you enjoyed this video, I would suggest you to like, comment, and let me know. And if there's something you think that I could have done better, feel free to let me know. And I can't wait to publish my next video. Please subscribe and hit the notification bell. Therefore, when I publish it, you'll be able to get notified. Okay? Enjoy.